Hi, fourth graders. We are on lesson 87 in math, and this lesson is called Remainders and Word Problems. All right, so think about that. Remainders and word problems. What kind of story problem might this be if it uses division, which will have remainders? Is it a combining problem? No. Separating? No. Comparing? Definitely not. Of course, it is an equal groups problem that might have a remainder. So in other words, these will be problems that either we will be doing some multiplication or some division to solve. Okay, so keep that in mind as we move forward. So what we have to be careful about is knowing that like I just said, it will be equal groups problems that we're doing today, and we will while solving these problems, we want to be careful to identify exactly what the question is asking. Don't assume that the question is, how do I put this? Don't automatically assume that you know the answer. Really pay attention to what the question is asking, okay? So I will give you an example of what I mean by actually jumping right into our first lesson practice problem, which I think will be the best way to teach you this part of our lesson. So here we go. Lesson practice on page 578. Okay, and we are going to go ahead and read the very first lesson practice problem. And we'll do both lesson practice problems before we start our star problems today. So, lesson practice problem number 1 says, use the statements below to answer problems A through E. So, first question, or the first problem says, tomorrow, 32 students are going on a field trip. Much bigger class than ours, right? And it says each car can carry 5 students. Did you notice that word each? That little word that automatically should get your attention to tell you that you are working on a story problem that will require you to write basically 3 sentences, you might say. The first one will be drawing a line and saying how many students per car or per vehicle. Okay, how many students per vehicle? Okay, and then, or you could have used the word car and cars as we have in that example. I'm just using the word vehicle, it means the same thing. Vehicles will go on the next line. Hold on one second while I steady the board a little bit more. Here we go, that feels better. All right, so as we've always talked about in the first line, we will have the word each or per or in a. That means the same thing. The second line, we put the plural form of that last word. And in the third line, we bring down, in this case, the word students. So whatever comes after that first number is what comes down into that third line. So now let's fill in what we know. Do we know how many students per vehicle, the number of vehicles, or the number of students? So in this problem, we're told there are 32 students going on a field trip. Not 32 students per car, but 32 total students. So we'll put the 32 right there. Then we find out each car can carry 5 students. So that means that we're going to put that 5 right there. Okay, so then obviously the question that we are bound to be asked is, well, how many vehicles? Okay, so now if these two numbers were easily dividable with no remainder, that would be nice. 5 times something makes 32, but it doesn't. So we're going to have to have a remainder, and then we're going to have to think about what do we do with a remainder? What does that mean? Okay, so let's go ahead and look at what the very first question is. It says, how many cars can be filled, or how many vehicles can be filled? So in order to figure this out, now we're going to take that number 32. I think I'll actually switch pen colors for you. 32 divided by 5. 5 times something to give us 32. And let's see. Let me move that a little bit over. There we go. So we know that 6 times 5 gives us 30. It's as close as we can get. We're going to bring down that 2, and what do we end up having? We have 6 with a remainder of 2. There's no other numbers to bring down, so we're finished. So that means it's going to take 6 vehicles and a little bit more for all of these children to fit. Well, that's kind of odd, right? So this is exactly what our story problems are about today. It's the remainders that you get inside of word problems. So let's see, what can we do? It says, how many cars can be filled? Well, this is 6 plus cars can be filled, but there's only 6 vehicles at this point. 6 vehicles are filled, and then it says, but how many cars will be needed? Well, we can't put 32 students into 6 vehicles. That just will not work. There will be 2 extra students. So we are going to need 7 vehicles to fit all 32 students. Okay, so letter A, you need 7 vehicles. I'm sorry, letter A, how many cars can be filled? We found out that there were 6 cars, 6 vehicles. And letter B, that because we have 2 extra students, we are going to need 7 vehicles to take all of them. All right, okay, so let's move on to the next problem. Okay, then the next problem says it's about coins. It's another equal groups problem with a remainder. And it says Tendai found 31 quarters in his bank. Okay, so maybe he has a little piggy bank and he finds 31 quarters. That's cool. If we were in class, I would ask you, how many of you guys still keep piggy banks? And I'm curious if you all do. Do you have some special ones at home? So this person, Tendai, found 31 quarters in his bank. That sounds like a total, doesn't it? And it says he made stacks of 4 quarters each. So that tells me in our next lesson practice problem that we have 4 quarters in each stack. So that's the very first thing, is write down that first sentence in a story problem that uses that word each or per or in a, any of these, whatever words are used that mean each. 4 quarters in each stack. Then I've taught you that in the next line, do the plural of whatever came after that word each. Do the plural of that word. Write the plural of that word in the next line. And then bring this word, whatever it is, in your story problem, bring that down, because that is the number that will also be in the total, the word and that will be in the total. So now ask yourself, do I know how many stacks or how many quarters? And if we look at our problem, it says he made stacks of 4 quarters each. Okay, so 4 quarters in each stack and 31 quarters total. So let's write number 31 there. So now we need a number that is 4 times something gives us 31. So what do? We can't multiply it easily, so we're going to divide it. We're going to take 31 divided by 4, and we say 4 times what gives us 31? Well, the closest thing I can think of is a 7. You know, like 6 times 4 would be 24. That's too small. More 4s can fit in there. Let's see. So I'm thinking 4 times 7, which gives us 28. We didn't go over, so that works. And then let's subtract. Well, 28 to 31, 29, 30, 31, right? That's a 3. Of course, you can cross it out and do it this way. 11 minus 8 is 3. 2 minus 2 is nothing, 0. And we have 7, remainder 3. And again, this is the key to our lesson today, is that we're not given a number that is very simple like 7 here. It is 7, remainder 3 is the number of stacks. So 7 stacks with like 3 extra quarters that doesn't fit into a stack of 4. So let's see the first question. And we've already pretty much done everything to figure out what the answers to the questions we will be asked. So let's see, letter C says, how many stacks of quarters did he make? Okay, so how many stacks before that remainder 3? There are 7 stacks. So for letter C, there are 7 stacks. Okay, then for letter D, says how many extra quarters did we have? That's the remainder. So we're going to write there was 3 extra quarters. I hope that's that you can still see that. Let me move this just a little. 3 extra quarters. And then the last question says, if Tunde made a short stack with the extra quarters, how many stacks would he have in all? Well, if he took that last 3 and he made 1 more stack, but with just a short stack with less than the whole amount of 4 quarters, then he would have 1 more stack, which is 8 stacks. Okay, here we go. Make sure you see that well. Okay, and that brings us to our star problems. Make sure you get this all down. Remember to pause if I'm going too fast. You can always stop and take a better, closer look. Okay, and remember too that if you are stuck, you can always text me, use mom or dad's cell phone and text me. The phone number, of course, is 916-402-1275. So you can text me if you have a question. You can email me if you like. But usually the best way to get a hold of me is to let me know that you need me by texting me first, letting me know who you are and that you have a question, and then I will make sure to answer you, probably give you a call. All right, so the first star problem we're going to do today is number 1, particularly because it is a lesson 87 star problem, and that's important that we do all of the lesson 87 star problems for sure. So let's get started. Number 1 says 91 students are divided as equally as possible among 3 classrooms. So 91 students among 3 classrooms. Very first thing we should be thinking is, Well, first of all, it's a lesson 87 problem, so we know it's going to be an equal groups problem with a remainder, a story problem with a remainder. That's our first clue. So 91 students divided as equally as possible among 3 classrooms. Then first question says, how many classrooms have exactly 30 students? And how many classrooms? Next it will say have 31 students. So think about that. There will be 91 total students, 3 classrooms. Let's begin our story problem. So number 1, we have a certain number of students. Which word did it use? Just used as equally as possible. So let's see. 91 students. I'm just going to use the word per. It's a nice, feels like a nice grown-up word I really like. So many students per classroom. Do we know what that number is? Think about that. Next, we should have another number that means the number of classrooms. Well, if you paid attention, I think you already know that there are 3 classrooms. Well, you can't add classrooms to a building very easily, can you? But you can certainly shift kids around. And that, I think, is what they're about to do. So let's see. How many classrooms have exactly 30 students? Oh, before we do that, we have one more piece of this puzzle. We know we're always told at least 2 pieces of the puzzle. Sometimes they give us a little bit more information just to see if we're really paying attention. But here they gave us only what we needed to know. So do we know how many students per classroom? Or is that one of our questions? It's one of our questions. Do we know how many students? Well, you probably think I'm being silly since you know very well that we were told there are 91 students total. And so there's some number times 3 that will give us 91. We don't know what that number is exactly, so we are going to divide. 91 divided by 3. Now, if it was 90 divided by 3, we would know that that's 30, but not that easy. Remember, these are problems that should have remainders, okay? So how many times does 3 go into 9? Well, 3 times. 3 times 3 is 9. We go ahead and do the subtraction. Make sure we line up everything. Bring down that 1 right there, and we say 3 times what number gives you 1? Well, there is nothing that gives you 1, so we're just going to put a 0 and say, well, 0 times 3 is 0. That's close as we're going to get, and we're going to subtract and have 1 left over. Now, if there was another number right here after this one, I would have to bring it down, but there's nothing left. So that means this little itty bitty one down here is our remainder. And there we go. This is the kind of problem I promised we would have today. So there are 30 students per classroom, and there's 1 extra student that is unaccounted for. So let's see. So there's 30 plus 1. Remainder 1 students per classroom. So what are we going to do with this little remaining child, right? So now we know, or we can figure out how many classrooms have exactly 30 students. Well, let's see. Can classroom number 1 have 30 students? Class 1, we have 90 students. So can't we say classroom number 1 can have 30? Classroom number 2 can also have 30. That's 60. And what about classroom number 3? What if they have 31? Couldn't that give us 91 total? students, which is what we have. So 1 extra student, right? So then to answer adequately, letter A said, how many classrooms have exactly 30 students? And the answer to A is 2 classrooms. 2 classrooms. Can you see that okay? 2 classrooms can have 30 students. And then B, how many classrooms can have 31 students? Letter B, 1 classroom. Whew. And there you go. That is everything that we need to have. 1 classroom can have 31 students. All right. So I'm hoping you can see how all the different things that you learned this year lead up to us being able to figure out a little more complicated problems. Okay, let's move on. We have number 7. Number 7 is a type of problem that I saw on some of the homework that I corrected that some of you are having difficulty with. So please pay close attention, as I hope you do with every problem I do with you, to number 7. If you're ready, go ahead and get started and I'll catch up. Okay. All right. Number 7 says, if y equals 4x plus 5, what is y when x is 4 or 5 or 6? So if you think back, this is a problem that we use for graphing, right? So if we know the x and the y's, then we can go ahead and graph points on a coordinate graph. So the first thing that I taught you to do, if you recall, was to go ahead and kind of keep track on a little chart, like this x and y chart here. Okay, so these are the numbers we're given. We're given 4 as an x, 5 as an x, and 6. So these 3. And the question is, what is y? So let's first of all try filling this in. We'll leave this top part alone, y equals 4x plus 5. And we're going to fill in this x with, or substitute the number 4 for the first x. So here's what we're going to do. We're going to simplify. Y equals 4 times this x. So did you see what I did? I just went 4 times 4. I replaced the x with a 4 plus 5. And then keep simplifying. We know parentheses go first. 4 times 4 is 16 plus 5. Okay, and so y becomes 21. So what we just did again is we took this 4 and we substituted it in here and we said 4 times 4 plus 5. So now what we're going to do is, oh, let's not forget to write it down. When x was 4, y is 21. Now I'm going to go back and I'm going to erase, well, we're going to rewrite it, I guess I should say, because I don't want you erasing anything. I want to see all your work, every part here. So now I'm going to go to, okay, well, y is something else this time. This time y is 4 times 5. Maybe I'll do it this way, 4 times 5 plus 5. Did you see the substitution that just happened? Okay, and then we say 4 times 5 is 20. Add another 5 and keep simplifying until you get y is 25. Oh, this is a very colorful table, isn't it? Y is 25. Okay, now we have to do it one more time, but this time we have to replace that x with a 6. Okay, I want to see all of this written, guys. I want to see all your work. So write each of these. Okay, so this time we're going to say y equals 4x plus 5. You actually have to write this again and again and again. Sorry about that, but that's just how it works. Y equals 4 times 6, this time, plus 5. So you've written y equals 4x plus 5. Now substitute y equals 4 times x, because remember this 4x is the same as 4 times x. Okay, plus 5. So y is 24 plus 5, and we know that that is 29. And that is the number 29 that represents the y here. Now I could take all this, I could draw a graph, the 0, the x axis here, the y axis here, and I could say, however I do this, I could say 421. That is 421. Remember? And continue on and graph all of those points, which I'm not going to do because that wasn't what we were asked to do. But I just want to see you to see how it can be turned into a graph if that is what we needed to do. That would be like the next step. Okay, so that's number 7. Let's move on to number 8. It says, a regular pentagon has how many lines of symmetry? A regular pentagon has how many lines of symmetry? Pentagon. Pentagon means 5, or that part, pentagon, means a 5-sided, flat, not 3-dimensional, a flat-sided closed shape. 5-sided closed flat shape. So that is like this. Let me draw you a pentagon. Maybe I think I will start like that. And then maybe like this. Oh, that didn't turn out too good. Let me try again. I want to draw you kind of a nice one. Maybe a little bit further out like that. And then come in a little bit. And then like that. Still not perfect, but I think you know what I mean. A regular pentagon is how many lines of symmetry? So the point is I can cut it there. Well, that's one line of symmetry. I can cut it here and it'll look the same. That's another line of symmetry. I'm going to keep tally. I can, let's see, I could cut it here. And that would give us another line of symmetry if this looked perfect. I could cut right through here. I could cut right through here. It's another line of symmetry. Where else could I cut? Let me think. 1, 2, 3, 4. Can you think? Can you see one more? Let's see. This way. There's 1. This way makes 2. This way makes 3. This way makes 4. And this way makes 5. So since it's 5-sided, you can make 5 lines of symmetry. Now it says, does a regular pentagon have rational symmetry? Do you see that problem? Does your book say rational symmetry? That is an editor's mistake. They didn't catch that mistake. It should say rotational symmetry. And yes, if I turn this pentagon any which way at any amount of degrees, 5 times I can turn it before it goes back to its original shape. So it does have rotational symmetry, and it would look the same every single time. Okay, so I'm going to go ahead and write that. The answer to B was yes. I'm not even going to take the time to write it for you because you guys are big kids, right? Practically adults. Just kidding, but You'll be there soon enough. Okay, number 9. It says 1/2 of the 32 chess pieces were still on the board. How many chess pieces were still on the board? Draw a picture to illustrate the problem. Okay, well, I don't have to draw a chessboard to figure this out. I can just simply write 32 chess pieces. Okay, and then underneath it, it said, we heard the word 1/2. So 1/2 of 32, we need to, this is a half. Here's the other half, right? Pretty simple. So we need to divide this into 2, divide 32 into 2 to figure out what each part represents. 32 divided by 2. Okay. And let's do the division. 2 times 1, 1 times 2 gets us as close as we can to that 3. 3 minus 2 is 1. Bring down the 2, and we put that 2 right there. And now we have, I'm hoping you immediately think, oh, 6 times 2 is 12. 6 times 2 is 12. Write that down. I have no remainder. This means that there are 16 pieces that make a half here, and another 16 pieces that make the other half there. And now we have drawn a picture to illustrate the problem. Okay. All right. Let's see. I would love for you to please go to number 12 and challenge yourself if you like with that, but we're not going to take the time to do number 12, so you can put an X on number 12. And then let's move on to number 13. Okay, so number 13 is a problem that says Alvin, must be one of the chipmunks, right? Alvin faced the sun as it set in the west. Okay, so let's just imagine Alvin. He is looking at the sun. All right, there he is. He's looking at the sun as it is setting in the west. I'm just gonna kind of draw a picture of Alvin. Here we go. He's gonna wear a cool shirt with a big A on it. That means, that stands for his name. Okay, so Alvin, and he is facing west. Let's see what else we find out. Then it says he turned 90 degrees counterclockwise and headed home. You know what would make more sense to me? What about if we actually put the sun in the west? Okay, so he's looking this way. Oh, I wish Corbin was here. I'm sure he would draw a super awesome picture of Alvin facing west. Remember it, north, south, west, east, north, south, west, and east. Like if we were looking at a map, we're here in California on a US map, right, in the west. So he's looking west. Now we find that he turns 90 degrees counterclockwise. Well, the clock goes this way, so he's not going to be turning this way. He's going to be turning counterclockwise this way. So if he turns 90 degrees against the clock, counterclockwise, then he heads home. His house is down here somewhere. Okay. In what direction was he heading after he turned? So if he was looking west and turned 90 degrees counterclockwise, he is now heading south. Isn't he? Okay. So that's number 13. Let's see. Not too bad for an illustration, was it? Took me a minute, but I think I got a pretty good illustration there for you. Not as fancy as some of you, as Isabella McCovey or Lydiana or Corbin or some of you artists, the rest of you artists would have done. Not not that I don't think all of you are artists, because I know that you were made by our wonderful Creator. You were made by our wonderful Creator, God. And so He created you to be creative, which means whether you feel like you're a great artist or not, you are all creative and you are all artists. So for some of us, it comes more naturally. Some of us practice more and we build our skills of artistry. And that's pretty cool. Okay, so number 21 is our next star problem. And number 21 says 14 times 22. And so 14 times 22, 2 times 4 is 8. 1 times 2 is 2. And go ahead and put down that 0 that stands for the 20 here that we're going to multiply 14 by, as we learned in our last lesson, lesson 86. Now we say 2 times 4 is 8. 2 times 1 is 2. Add these two together. We have 8 and 10 and 3. So number 21, the answer is 308. Now I am not satisfied with seeing just 14 times 22 is 308. Not at all. You need to show all your work. Okay. All right. Now we have number 22 as star problems, number 28, and number 29. And I think what I'm going to do is jump right to number 28. So take number 22 and go ahead and put an X on number 22. Make it a challenge for yourself if you like. But for lack of time and trying to keep our videos short and do the most important problems, I would like to look at number 28 together. 16 times 1,000. 16 times 1,000. 1,000 is a very large multiple of 10. All we have to do is write down the 16 and 3 zeros. Then go back from the right. 1, 2, 3, comma. And our answer is 16,000. And then we have number 29. Number 29 over here, I'll just do it on the same board without cleaning it. It simply says 263 times 100. Ah, look at that. A multiple of 10 again. We could do this in our heads. 263 times 1 is 263, and add 2 zeros. Okay. And that completes lesson 87. May you be blessed, and go ahead and take a break if you need to, but go right back into doing your non-star problems, please, because tomorrow we're going on to the next lesson. Now we are doing shorter videos with 1 lesson a day. All right, love you guys, and I miss you, and you'll see me tomorrow on the next video. Bye.